Four of Us, Four Ideas, Group 4. María Camila Prada, Juan Manuel Páez, Valeria Nao, Valentina Lastra. We need the secret formula to help our school recycling. How can we do this? We need to know how to make bioplastic with potato starch. That's why we'll present. The secret formula to recycling is bioplastic. Research question. How can purified water have a great quality of state when the volume of water has not been purified? By evaluating attributes within a solid state and a microorganism rate. Then how if one of these stages has a variation, water purification can be affected.
Research question. How bioplastic made by the starch components of potato can replace or have the same qualities than standard plastic by using different methods of purification like resistance, flexibility, resistance to heat, and water absorption? Possible questions. Now you have the containing potato plastic, it's important to notice all the properties of each substance. Then try to evaluate your purpose. Do you think this type of plastic is actually biodegradable? Test the plastic to find out based on its common characteristics. Now, evaluate how this natural composure of plastic is made, how industries could extract the energy to create the starch, and so take into account how normal plastic is made. Take into account all the raw materials needed. Explain the meaning of bioplastic and biodegradable. Discuss the advantages and disadvantages of creating this type of plastic.
Polymer is the structure of a great number of components that repeat themselves several times, as it can be organic or synthetic. Usually, organizations use synthetic polymers. This is the difference between the normal plastic and the bioplastic. That's why it's important for us to understand the similarities and differences, for us to create a new type of plastic, creating the pH regulation of the normal type of 7, which is indicated in the center of the chart with a green color.
Water resistance or absorption. Almost of the plastic capacity to absorb and retain certain amounts of water, its ability to determine if it can hold it and not let it go through. To determine dimensional and mass changes like swelling that are caused by water absorption. With a specific volume of water, as for example 200 milliliters, and then measure what had escaped of the one which actually was contained then, with different percentages, it's possible to define the capacity of the bottle to hold the amount of water. Residuary water volume.
Independent variable, initial water volume, 250 milliliters, uncertainty of 12.5 milliliters. Dependent variable, remanence of water leak volume, 250 milliliters, uncertainty of 12.5 milliliters. Control variable, using water with the same characteristics as it doesn't affect the resistance in any particular aspect.
Resistance to heat, as to use water by heating the water and measuring the temperature, then add the plastic as to analyze its ability to resist heat. If it starts to lose shape, so it's possible to understand its capacity by placing a square of plastic with known measurements and then again measure if there was any possible change in rate of measurement after a certain temperature, 120 degrees. Flexibility. Ruler measurement in comparison to another plastic data to determine changes in mechanical elasticity and tensile strength, using centimeters as the unit with an uncertainty of 0.25. It would be good to determine the strength applied, but it's not possible when using personal strength with no machinery. By using different lengths of plastic, it's possible to determine the changes of rate among each in comparison. Quantitative method for bioplastic. Which characteristics will you measure? Resistance, weight, as to have two bases to identify how much weight it can contain, till it plunges into a low direction, using newtons as a weight possible measurement. Impact strength, unit symbol newtons, as to measure also the height that it may unsettle and relocate position from the starting point, with a graph that compares both weights. Sees a normal amount in comparison to the affected. Independent variable, weight, newtons x-axis. Dependent variable, distance, length ruler, centimeter ruler, uncertainty of 0.1, y-axis. Control variable, longitude of the plastic.
Conclusion and evaluation. Interpretation of data and relationship of variables. Results are compared and calculated with reference accepted values. For this experiment, we realized four different methodologies to prove the validation and strengths of bioplastic, always in comparison with the customary plastic we use daily, based on how every small source might be useful to identify any weaknesses and setbacks, with the structure and purpose of the substantial. Therefore, each chart has 5 trials for each variable, dependent or independent, also counting with 3 trials for each type of plastic identified by bioplastic and standard plastic. By analyzing the first table, it's possible to verify the research question using the property of resistance, by means of 5 different measurements of newtons from 5 to 25 N. Consequently, it's easy to realize from the tables and graphs how bioplastic has less resistance to weight, as it has a tendency to bend when newtons are added, conforming an average range of 1.14, 1.56, and 0.88 in the bioplastic regulation. Thanks to the graph which compares both types of plastic, you may realize the standard plastic has a lower average range of resistance since it is of 0.08, 0.02, and 0.14. This means the characteristics of bioplastic according to resistance are completely unvalued, since it didn't achieve the meant purpose to have a similar tendency of normal plastic. There was an actual difference of a prescribed 0.16 to 1.48 between each average of both plastics. Within these two slides, we might see how the comparison of the two microorganisms found in the water before and after using the filter is shown. By crushing the charcoal and using the bottle, we might see how the water drops and purifying what ingredients might have fallen from the toxic water.
Independent variable. Different lengths of the plastic, centimeter ruler, uncertainty of 0.1. Dependent variable, elastically measurement, newtons meter. Control, the same volunteer to apply the strength in the material used.
Chemistry behind plastics. Alkenes, unsaturated hydrocarbons which contain a carbon double bond, have double bond increases the relativity of reacting with other groups. By this mean, alkene undergo additional reactions through hydrogen and so with hydrogen halides. In this addition, reactions causes chemical reactions with other alkenes, which form a long chain of plastic. We might also observe how we crushed and peeled the potatoes, so using the distilled water and using the process mentioned below in the other diagram, we could create the starch. You might imagine our happiness by finding out the starch at the bottom of the beaker as a white substance. Another important aspect to analyze from plastic properties is flexibility. This characteristic was deliberated by different extents of strength. These assets were categorized from Newton's measurements to stretch, using the piece of plastic and then measure how it affected the length with a ruler. As the table shows, the quality of bending easily without breaking had different values. Bioplastic had an average range of 17.4, 19 and 18.6, showing it had a really flexible property of measurement which was even higher than expected. Actually, both plastics in the same shape achieved really different comparisons. Every component from the potato starch was really flexible, accomplishing an unexpected rate of length. Even if the results were amazing, they didn't achieve similar or a correlated relationship with the standard plastic, which was the nearest to 0.1, with an average of 0.05, due to how flexibility is not a common factor of plastic. Resistance to heat had an outrageous pattern of deviation in the results of both graphs and tables. This table had a tendency to show an almost constant decrease in reaction time when the temperature was increased, as both achieved the maximum temperature point of heat for plastic, which was 120 degrees, which remained at exactly 1 second. Another important aspect achieved was the optimum point when it reached the temperature of 135 degrees. That's why it reached the point of zero. There was this particular statement of how both plastics actually accomplished the standard rate and optimum at the same temperature. Another constant was how both plastics gradually decreased by each trial passed. Thanks to this comparison, it's easy to get the average rate. For example, for the bioplastic it was 0.76, 0.76, and 0.84, which shows a lower capacity to resist heat, since it actually demonstrated that its composure died sooner than normal plastic, not having great properties of reaction time to heat. Meanwhile, the resistance to heat of a standard plastic is from 0.68, 0.76, and 0.72, which means the property is the one which has the less difference between products. Bioplastics had a great differentiation.
Independent temperature decrease, uncertainty of 0.5 degrees. Dependent resistance to heat, reaction rate, time, is exponent minus 1, uncertainty of 0.01. Control using water with the same characteristics as it doesn't affect the resistance in any particular aspect. At last, water resistance was another characteristic for the efficiency of plastic. Plastics provide the necessary balance of properties that cannot be achieved with other materials such as color, lightweight, soft touch, and resistance to environmental and biological degradation. Between them, you might find one of their main functions, which is a container to retain mostly liquids. That's why proving water resistance was easy, but at the same time, really important to measure. That's why standard plastic had a rate of 0. It was produced with the same purpose. Although the water resistance in the bioplastic didn't accomplish its mission as expected, based on the table the material had a lot of leaks. From an average rate of 0.66, 1.12, and 2.14 from 250 millimeters of water. In comparison, everything was really unexpected, and the material was unsuccessful. There was no tendency or pattern in the results, more than how each trial there was value of the plastic capacity. Although by systematically applying statistical and or logical techniques to describe and illustrate, condense, recap, and evaluate data, you might understand the two opposites from results.
Elastic measurement analysis. The bar diagram makes it easier to compare sets of data between the two chosen groups or variables. Having the different trials among each other, it's quite important to contrast and analyze the different goals between the relationships among the two axes and the type of plastic, making it easier to solve the research question to discuss big changes in the data obtained and why it resulted in a certain way. As you may observe from the bars almost in each, the bioplastics have an extreme difference from the standard which prove the validity and possibility of the use. Analysis. With these tables, there is quite an aspect how everything may evolve from the increment of weight within the distance from the table to how the material bended. There are some evident error bars to connect the possible range, even if they don't overpass the 0.5 centimeters perimeter. The reason it shows the comparison of traits is standard and bioplastic due to the uncertainties that differ on the used material, which can actually describe the possible or limited aspects of the ruler. Where each aspect identifies, there can be a variety of precision. Even with this material, thanks to the graph, it's easier to analyze how the lines from standard plastic don't overlap 1 centimeter, meanwhile the lines from bioplastic may reach the 3 centimeters of variation. Even with the error bars, they may identify information that we didn't have knowledge of. Based on this graph, you may identify how error bars are graphical representations of variability of the data and use of graph to indicate the error or uncertainty in a report measurement. Analysis. To give a general idea of the precision in a measurement as to also identifying how far from the reported value the true and error-free value might be due to this standard deviation of uncertainty, which in this case helps to compare two quantities if various other conditions hold. The remains of how valued is the bioplastic, which isn't a scientific proof, it's important. Analysis. Identifying whether there is a statistically significant as they can suggest the goodness of it. While determining the functions and equations used for the variable, it's important to understand how this, with the score equipment, there can be a huge contrast among the variation of data. Now manipulating data and learning for future occasions may be easier to understand.
Evaluation and improvements, overall quality of the procedure used in data collected, significant strengths and weaknesses in the process, equipment and management of time. One of the main errors or factors that can affect the procedure varies depending on each property. In the first property of resistance, it was improvised when using the base that supported the plastic. For that reason, with bases designed specifically to measure the resistance of the weight, could have been used to obtain greater quantities and percentages of ability. For the variable of flexibility, there are materials and objects used mainly to stretch objects, with two claws and bases that are dedicated to stretch them to be specific forces. However, since the required industrial elements are not in the school, we use the force applied by the same child and thus measured in newtons by similarity. Of course, using the same person, but this information turned out not to be very viable or useful because they could obtain better results with other technological equipment. This information was more useful to determine a surface characteristic of the plastic.
With the property of resistance to heat, it turned out to be the best type of research due to its precision and the ability of plastic to melt at a specific temperature. For this reason, several patterns were found and the materials required were typical of the laboratory. In addition to this, in terms of time, it was very useful due to the seconds that were required to fulfill the objective. However, I always create the problem of cleaning since it was difficult to clean after the melted plastic remained in the beaker, but all results were viable and useful.
Finally, the water resistance. According to the normal properties of the plastic, the water resistance is completely good. In a normal product, the results were completely zero, and if its qualities of the pressure you experienced with understanding that when the handling time was precise. There were simple values and constants that with the pattern were predictable. On the other hand, there were some mishaps in terms of properties of the plastic that we made. Did not meet the requirements, and it was interesting to see the errors of their ability to meet each property. On the other hand, when evaluating each capacity and noticing the differences, it is easy to identify how well the question was answered. The qualities were not equal, but the procedure in theory was correct.